Another Math Studies Paper 2, question 3, that's from November 2015. Question 3. The weights of sheep on a farm are normally distributed with a mean of 100 kilos and a standard deviation of 8 kilos. So that's already telling me the mean, mu, and the standard deviation, sigma. Question 8. Sketch a diagram of the distribution of the weights of the sheep on your diagram. Label the mean and label one standard deviation above and below, one standard deviation below the mean. So I try to draw a bell curve like this, a bit round, going down and making sure that it's not going to cross the x-axis. Then in the middle I will have the mean, and how bright is this? That's related to the standard deviation. So what are they asking me? To make sure that I label the mean and I label one standard deviation above and one standard deviation below the mean. So these values need to be labeled. Okay, so I need to write down the 110 and then 110 plus 8, 118, and 110 minus 8, 102. So all these values need to be here. I make sure that I write down 110, 118, and 102. That's all I need for the question A. Question B, a sheep has a weight of 94 kilos. Write down the number of standard deviation that this weight is below the mean. So that's 16 from the mean, but they want to know how many standard deviations. Standard deviation is 8, so divided by 8, that makes 2. So 2 standard deviations away from the mean. That's solution to B. BII, find the probability that a sheep chosen at random weighs more than 94. Probability weighting more than 94. So I need to draw that in a diagram. What does this mean? Probability more than 94. I have my bell curve and I need to show more or less where the 94 is. I know that I have my mean. That's my mean. The standard 94 is 2 standard deviations, 1 and 2. So more or less here is my 94. 94. And I'm looking for this area. That's area from here till the end. Give me the probability of bigger than 94. This is what I need to draw now. If I want to have the value, I need to use the calculator. I need to go to we draw to normal CDF. What do I need to put in normal CDF? The lower value. What's my lower value? The 94. What is my upper value? Infinity. How do I put infinity in the calculator? Well, I could put 9 millions if I want. 99999 is almost 10 millions. I need to put my mean, which is 110, and I need to put the standard deviation, which is 8. That gives me a value 0.97724 and so forth. If I want the 3 significant figures, it's 0.97 three significant figures. 97, 7. So I could go back here and write that's the area. 9, 7, 7. That's my answer. Question C. Find the probability that a ship chosen at random wins between 88 and 116. Find the probability that a ship chosen at random wins between 88 and 116 kilos. So now I have the two values. I have the upper value and the lower value. I think that's even easier. So again, I write down the probability, but now my weight is in between 116 and 88. I need to draw the bell curve, a schematic of the bell curve. I have it again. I have my 110, which is my mean. So where do I draw the 116? Well, it's not very far away. It's not gonna be very far away from the mean. It's less than 1 standard deviation. Let's write it here. Let's label it. While 88 is much more farther away. Let's put around here. It doesn't need to be perfect. And what I'm asking is the probability, which means this area. I need to shade the area. Now, if I want a value, I need to use the calculator. I need to use the normal CDF function again. Remember that you need to start with a lower value. So let me put that here. A lower value, an upper value, the mean, and the standard deviation. That's what you put in your calculator. There is no need to put an infinity. Now it's very clear. The lower value is 88. The highest value 116, the mean 110, and the standard deviation is 8. Using the calculator, you will get the value of 0.77039 and so weiter. We want 3 significant figures, so we have the 7, one more. That's the three significant figures. That is my answer. CII. The farmer weighs 160 sheep. Find the number of sheep that he would expect to weigh between 88 and 116, the same values of before. That's, I think, an easy one. We have calculated a probability, so they weight between these two values, and now this probability on the 160 sheep will give me the number of sheep. So I know how many sheep I have, and I know the probability that they weight between these two values. It's just the value we calculated before. Well, that will give me the number, the amount of sheep, 160 times the 0.770. Okay, how much is that? That makes a total of 123.2 sheep. Remember that we want 3 significant figures. Those are my 3 significant figures. That will make 123 sheep. That's the answer. Question D. Given that 70% of the sheep weight less than a certain value, what is this value? So here we are going to need again the calculator, but we are doing the inverse question. I know the probability, I know the area, but what's the value? I can draw the bell curve and say, well, which area is 75%? Well, it needs to be bigger than half of it. Let's put it here. Suppose that this region is this 75%, or if I prefer 0.75. But now, what is the value? It's a less than. Less than is exactly what I have in the calculator. If I use in the inverse of the normal distribution. If I use the inverse of the normal distribution, this is what I'm going to get. So I need to go to the distributions, and I find the inverse of the norm. What are they going to be asking me? They're going to be asking me about which area you are looking for, and again, what is your mean and your standard deviation. The area, remember, is not a percentage, so I need to put a number, 0.75, don't put 70%. 0.75. What is the mean? 110, standard deviation is 8. If I put these values, I found out the result is 115.395 and so on. I want 3 significant figures, 115 kilos. So if I'm looking for ships weighing less than 115, that's going to be 70%. So that's the easy question. Remember that if they're asking me for more than, I will need to reverse the question as a less than, because this is what the inverse norm is giving me. And I need to use the idea that in total, this is 100%. So 1 minus one region will be the other region. But this one was one of the easy questions. Well, that's what they asked me in the last question. A ship is chosen at random. Its weights within the central shaded region on the following diagram. So what is this? Between A and B, and I have 30% in this region, 30% in that region. Find the values of A and B. So that's the exercise I wanted to explain before. I want to calculate the central area, knowing that 0.3, 30%, is higher than A, and 0.3, 30%, is lower than B. But the only thing I can do in the calculator is smaller than. So I need to put 2 steps. Smaller than A is going to be this, and smaller than B is going to be that region. So I need to do some little calculations. To be smaller than A, what is this area then? If I know that this is 30%, that area that I have now is 0.7. Yeah, 0.3 plus 0.7 is 1. And now in this other region, that's easy. I don't need to change anything. I'm looking for an area of 0.3. So I need to go to the calculator, the inverse of the normal lower than 0.7 with my mean, my standard deviation, that corresponds to 106.807 and so on. 3 significant figures, 107. That's my A. Oops. What's my B? Less than 0.3 with the same mean and standard deviation. That gives me in the calculator 104.195 and so on. Remember, we just want 3 significant figures, is 114. That's my B, and that's the final answer.